Hi AAT, this is section 4.5, solving radical equations. So we're going to be solving these equations that have a square root or a cube root or maybe even a fractional exponent. And tricks to do that, we're going to isolate the radical. We're going to get one of the square roots by themselves. If there's two, we're going to separate them to two separate sides. If the radical is square root, we're going to square each side. If the radical is a cube root, we will cube each side because that's doing the inverse operation. Solve the resulting equation and check your answer to make sure you don't have extraneous solutions. And that's super important. On these types of problems, you have to check your answer at the end, because when we square something, like if we have the square root of x equals -1, I know that's impossible. There's no way to get a negative number when I have a square root. But if I square both sides of this equation, I get x equals 1, which is a solution, but it's an extraneous solution because the square, if I plug this answer back in, square root of 1 is not -1, so we would have to throw out that answer. So you could do everything right, but still get answers that aren't actually true solutions, so you have to check them. Okay, so A here, first thing we want to do is isolate the radical. So we're going to bring that 4 over to the other side. And we get square root of x minus 3 equals 4. And then we've isolated the radical, so we're going to get rid of it by squaring both sides. And if you square a square root, that's just x minus 3. And 4 squared is 16. Add to both sides. And x is 19. Got to check before we circle that answer. If I plug in, make sure you go all the way back to the original problem, 19 minus 3 minus 4, and is it equal to 0? This is our check step. 19 minus 3 is 16, square root of 16 is 4, and 4 minus 4 is equal to 0. So I've checked, and so I can circle that as my answer. Okay, so I'm going to pause. You pause right here and do B. Okay, so on this one, if you did everything right, subtract 5 both sides, added 1 to both sides, squared both sides, you'd end up with x equals 5. But if you checked it, you would see you'd get the square root of 2 times 5 minus 1 plus 5, is it equal to 2? And that would be 10 minus 1 is 9, square root of 9 is 3, and 3 plus 5 is not equal to 2. So this is an extraneous solution. And we would throw out that answer. So make sure you write no solution. Sometimes you'll just throw out one answer and there's another answer that works. But if you throw out all the answers, there's no solution. Now, you may have noticed back here at this step, when I got a square root equal to a negative number, I already knew that there was no solution. So if you get to that step, and it's a square root, not a cube root, square root can't equal a negative, you can go ahead and jump to no solution. Okay, so letter C. So fractional exponent, power of a root, is the same thing as a square root. So the radical is already isolated. So we're going to go ahead and square both sides. Now be careful, when you square a binomial up here, you have to FOIL. So I'm going to make sure I know we're going to FOIL over here on the left side. So I got x minus 2 times x minus 2 by squaring the left side. And on the right side, if you square a square root, you're just going to get 2x minus 4. So let's FOIL that out. First would be x squared, outer negative 2x, inner negative 2x, and last is 4. Okay, now this is quadratic. It has a square, so let's get everything to the same side and combine like terms. So I'm going to combine like terms first. X squared minus 4x plus 4 equals 2x minus 4. Subtract that 2x from both sides. X squared minus 6x. I'm going to go ahead and add this 4 to both sides. Plus 8 equals 0. So this is the zero product property. You got it. get it equal to 0 before you factor to find your solutions, zero product property. So if we factor here, we get x minus 4, x minus 2. Remember, on a quadratic, we set each of them equal to 0, x equals 4, and x equals 2. So those appear to be your solutions, but you would need to go and check them both. On this, I'll go ahead and tell you they both work, but you've got to plug in 4. If you plug in 4, I can see I'm going to get 8 minus 4 is 4, and the square root, remember this is a square root, the square root of 4 is 2, and 2 equals 4 minus 2. So that will check, and I'll go ahead and tell you 2 works as well. But make sure you got to check them both, because sometimes one of them will be extraneous and one of them will work. That actually happens pretty often. Okay, so same thing on D. You give that a try. So here's the answer to D. Had to, again, FOIL the right side. Radical was already alone. You squared both sides. And then when we got everything to the same side, we ended up with x squared minus 4x minus 21. I factored it and used the zero product property. But when I plugged them back in, x minus 3 did not work. I ended up with negative 6 on the right side, and a root can't equal a negative number. So this is the kind where I throw out one answer, but the 7 worked just fine. Okay, so moving on to E. E is a quoric root to the 4th root. So instead of squaring both sides, we're going to do each side to the 4th, which doesn't really make a difference. We have a root equaling a root. They're both 4th roots. So if you do a 4th root to the 4th, it just ends up being that 2x minus 1, whatever's in the radicand. So now it's super easy. Subtract x from both sides. X minus 1 equals 1. Add 1 both sides. And we get x equals 2. Let me go ahead and check it. If I plug in 2, I'm going to get 4 minus 1 to the 4th root. And over here I get 2 plus 1, 3. And the 4th root of that. So this is the 4th root of 3 and the 4th root of 3, which is definitely equal. I don't know what the 4th root of 3 is, but they're definitely equal. So your answer is x equals 2. Okay, number F, letter F. So this one's kind of interesting because first step was to isolate the radical. And here we have 2 radicals. They're 1 on each side, but we also have these coefficients in front of it. It's okay if you go ahead and square it with those coefficients right in front of it. There's no way to totally get rid of those. So if I square both sides, because these are square roots, make sure you square that 2, and then a root squared is just its radicand. 3 squared is 9, and then you have just x minus 2. Now it's just an easy equation. You're going to distribute and solve for x. 4x plus 32, make sure you distribute, equals 9x minus 18. Subtract 4x here. And I get 32 equals 5x minus 18. So maybe we should add 18. 5x equals, that's 50. Divide by 5, and x is 10. Make sure you check it. If we check it, I can see I'm going to get square root of 18 over here, and let's see, square root of 18 over here, and square root of 8 over here. So I have 2 root 18, and I'm trying to see if it equals 3 root 8. Now, before I make a decision, I need to make sure I simplify these square roots. 18 is 9 times 2, so that 3 is going to come out, so that's 6 root 2. And 8 is 2 root 2, so the 2 is going to come out, and that's 6 root 2. So those are equal. So x equals 10 is our answer. All right, so next page, flip on over. Okay, x squared plus 7 equals x plus 1. So when you do this, this is another situation where you're going to have to make sure you FOIL the right side. So I'm going to pause right. Okay, when I FOILed the right side, I ended up with x plus 1 times x plus 1 because I'm squaring both sides. And I got x squared plus 7 equals, foiling it out and combining like terms, equals x squared plus 2x plus 1. And the x squared subtracted away. That's always nice. And I ended up with 2x equals 6 and x equals 3. Make sure you check, but when you check, that does work. Okay, so here's the weird kind. This, I think, if we were going to put a star on this page, this is the hardest type of these. And that's when you have two roots, and the root on this right side is a binomial. It's a root times or plus another number. So when we do this, make sure we have a root on each side, not two roots on the same side. A root on each side. So if we square everything, the left side's just 3 minus x, but the right side is root x plus 7 plus 2 times root x plus 7 plus 2. That's a FOIL situation. Again, that's treated like two binomials. So first, a root times itself, we're going to take our time going through this, is just the x plus 7. That's our first. Root x plus 7 is x plus 7. Outer is 2 root x plus 7. 2 times root x plus 7. That 2 can't go in there. Inner is also 2 root x plus 7. And last, 2 times 2 is, of course, 4. So far this looks a lot uglier than it started out, but we got rid of one root. But now we have these two roots. So let's combine like terms. 3 minus x equals, okay, I got an x, nothing to combine that with yet. I got 7 plus 4 is 11. We'll put those together. And these are like terms. A 2x plus 7 and 2 root x plus 7 is 4 root x plus 7s. Just adding those coefficients. Okay, so what do we do now? We still have a root. So now we need to isolate this root. So I'm going to subtract x from both sides, and I'm going to subtract 11. So I get that root by itself. So 3 minus 11 would be what? Negative 8. And we got negative 2x. And then we have equals 4 root x plus 7. So just like I said on the previous page, I can go ahead and square both sides here. It doesn't matter if I have a coefficient, just make sure I square it. I would not divide by that 4 first because I'd end up with a fraction to have to deal with. I'd rather not do that. So we're going to go ahead and square again to make sure we're getting rid of the second root. So we're going to FOIL on this side. This is the step that people forget. Don't forget to FOIL. So another FOIL situation when we square it. And if we square a 4, we get 16. If we square a root, we have x plus 7. So first is 64. Outer would be, what's that, 16x. Inner is also 16x. And last is plus 4x squared. Equals, I'm going to go ahead and distribute that 16. So that's 16x plus 16 times 7 is 6, 112, I think. Yeah. Now we're going to combine like terms. I can already see I have a 16x on both sides, so I'm just going to kind of subtract one of those away. I have an x squared, so I need everything on one side equal to 0 because it's quadratic. So I'm going to put that 4x squared first. And then I got that 16x. And then I'm going to subtract this 112 to the other side. Okay, and 64 minus 112, I think, is negative 48. Okay, so now we got it in quadratic form, so we need to try to factor it. Ooh, I'm out of space. So I'm going to pull out a 4. I always try to pull out a GCF, and I'm left with x squared plus 4x minus 12. So that's a little easier. And then keep that 4, and we got x, minus 2, and x plus 6, I think. 6 times 2 is negative 12. 6 minus 2 is 4. Use our zero product property. If we divide by 4, that just goes away. So we get x equals 2 and x equals negative 6. So if I plug them both in, and make sure you plug them both in, 2 will work. I'll get square root of 1, which is 1. And on this side, I'm sorry, 2 does not work. I do not get 1 on the right side. So 2 is extraneous. If I plug in the negative 6, I get square root of 9 is 3. And I get negative 6. I get square root of 1 is 1 plus 2 is also 3. But really take your time to check those. So there's only one answer on that crazy long problem. Okay, I'm going to stop there and we'll come back and do the last few problems together.